Okay, we are now on question number 33. And I am coming back to that, sorry. Ignore that for a minute. We're going to come back to that and do that as a separate problem. So we're starting at 38. All right, we're good to go. This problem here, you are using the formula for arc length. So S is equal to, wow, it's doing some weird things. S is the arc length, is equal to the angle in radians times the radius. So for the first one here, arc length is what we're trying to find, is equal to the angle, which is pi over 4, times 6. So this gives you 6 pi over 4, which simplifies to 3 pi over 2 inches. For the second one, we're missing the radius. So we have the arc length of 15 pi. We are given the angle, which is 5 pi over 6. And we're solving for the radius, which would be in inches. So we are actually going to divide, which is the same as multiplying by the reciprocal. So 15 pi divided by 5 pi over 6, which is multiplied by 6 over 5 pi. Because division is the same as multiplying by the reciprocal. 5 goes into 15 3 times. The pi's cancel, and 6 times 3 is going to give you 18. So the answer should be 18 inches. Finally, S, which is 30, is going to be equal to the angle times the radius of 10. If you solve that, divide by 10. Our angle in radians is going to be 3 radians. So that was a nice, quick, easy problem. These are not so quick and easy because these are all the word problems. Okay, so draw a graph as distance as a function of time. So I'm going to do this first up here. So this tells you at t equals 0 seconds that we are 160 centimeters away from the wall. So this is time. And this is the distance from the wall. At 3 seconds, they tell you the ball is closest to the wall at 20. It's going to be your minimum. And then at 6 seconds, again, it's furthest from the wall again, at 160. Here at 160. So this looks like, to me, a beautiful cosine curve. And that's one little portion of it. It didn't tell you to sketch anything more than, like one period of it, but be careful when you see these questions. Sometimes it might say sketch for the first 12 seconds, and you'd have to do 2 periods of it. But here, this is all we need. So as you were looking at that, we need the trig equation. So this was A. To find the trig equation now, we need the maximum, which is 160, the minimum, which is 20. So A is going to be equal to maximum minus minimum divided by 2. And again, we're starting at the maximum for cosine. This is a cosine curve. Starting at the maximum, so it's A is going to be positive. So this is 140 divided by 2, which is 70. By the way, this is the calculator section, so you're allowed to finally use that calculator. B is going to be 2 pi over the period. The period is 6, so B is pi over 3. C is going to be this x value when this cosine period starts is 0. And D is max plus min divided by 2. 180 divided by 2 is 90. So this equation is going to be y equals 70 cosine of pi over 3x, there's no phase shift, plus 90. Now, what you're going to do next, I don't have a calculator on this, so I'm going to just describe how I would do this. You're going to put this equation in y equals to in your graphing calculator, and you should end up with the same graph. So when you're going to look in your table of values for x equals 5 and it's going to tell you that y is equal to 125. So the distance is 125 centimeters. Now, the next piece of this, again, I don't have the calculator. You're going to put y equals that equation in your calculator. Remember, you're going to put this in as looking like this. Sorry, divided by 3. X, close the parentheses, plus 90. That's how it should be in the calculator. And that's y1. You're going to be putting y2 equaling 40. So we want to find the first time the ball is 40 centimeters from the wall. So when you do that, you're going to go to second, trace, and intersect. And this, you're going to get to the left of it, get to the right of it, press enter, hit guess, and it's 2.260 seconds. Please pay attention to the fact that it has to be correct 3 decimal places, or 3 places after decimal place. That means to the thousandths place. Next problem. Sarah is writing that Ferris wheel. So this is our classic Ferris wheel problem again. Again, it asks not for a graph, but I really can't do the problems very easily without the graph, so I'm going to quickly do this. So at 3 seconds, she's 80 feet above the ground. Do a quick sketch that's not necessary. At 7 seconds, Sarah is at the lowest point, which is 20 feet above the ground. And then again, at 11 seconds, now how do I know this is 11? Well, I know that this is half a period. This is max, this is min. This is 4. So this is 4. If we add another 4, that's going to get us back to our max again. So this is a cosine function, which is drawn very strangely. Let me fix that. Cosine function with a period of 11 minus 3, which is 8. So to do the trig function, y is going to be equal to a is max of 80, min of 20. So it's a is max minus min divided by 2. 60 divided by 2 is 30. So this is positive 30 because we started at the maximum. Cosine b is going to be 2 pi over the period, and we said the period was 8. This is pi over 4. X. We have a phase shift because this x value c starts at 3. You have to watch parentheses here. So you really need a double set of parentheses here. And then plus d. D is going to be equal to max, which is 80, plus min, which is 20, divided by 2. 100 divided by 2 is 50. So this has got an A, a B, a C, and a D in it. All right, at 11.5 seconds. So you're probably going to have to change your table in your calculator to go up by 0.5s. So you go to second table set and change that how much it goes up by 0.5. And when you do that, you go to where x is 11.5 in the table of values at second graph, and y is going to be equal to 77.716 seconds. We want to determine the first 2 times, so make sure you answer this correctly. It's 2 different answers, where Sarah's height is 70 feet. So again, y1 is going to be your equation, which is 30, cosine, parentheses, double parentheses, excuse me, of pi divided by 4, close the parentheses, another parentheses, x minus 3, close that parentheses, and the other one, plus 50. y2, you're going to be putting in 70, and then you're going to go second, trace, and intersect. And you're going to move your cursor to the first time when it's 70, which is probably about like here-ish. Go to the left, to the right, and enter at guess. And that's going to tell you that this is at 1.929. And second time it's 70, left, right, and enter. And that is at 4.071 seconds. It is not okay for you to round incorrectly. So make sure you are labeling these with the units and that you round to the 3 decimal places. 42. Ocean tide dock, first low tide. Okay. So I, again, sketch and graph and label a graph. So this is time And this is hours after midnight. And y is depth of the water. So it is telling you here at midnight, so this is at 0, which is midnight, the water is 2 meters. At 6:30 a.m., so 6:30 a.m. is really 6 and 30 over 60. Sorry about that. Which is 6.5. So 6:30 is really at 6.5. Is the first high tide, and that first high tide is a depth, wow, it's doing weird things here, of 8 meters here. Pen's getting tired. So that's half of a period because it's going from here to here. And again, we need the other half of the period. So we have to double that. So that's going to get you to 13. And 13 is really 1 o'clock because it's clock time, like military time, like 1300 hours. So again, this is negative cosine because you're starting at the minimum. Your maximum is 8, minimum is 2. So we're going to take it through the process of getting the function. So A is max minus min divided by 2. Now, that is going to give you 3, but we know this is going to become negative 3 because cosine is a negative cosine, so A is negative. B is 2 pi over the period. The period is 13, so it's 2 pi over 13. C, the x value where the period begins is 0. And D, max plus min divided by 2. 10 divided by 2 is 5. So this equation is y equals negative 3 cosine of 2 pi over 13 x plus 5. No phase shift. Suppose a ship requires at least 3 meters of water so it can dock. So determine the earliest possible time that the ship can dock. So you're going to go down here and you're going to put this in the calculator. It's y1. And this is 2 pi over 13 x, close the parentheses again, plus 5. And y2, it can dock when it's 3. So this is question number 42. So it wants to know the earliest possible time, 42, that it can dock. So that is going to be, you're doing second trace intersect, and this is going to be at 1.740 hours, which is about 1:44 a.m. 48. Got 2 more left here. This is point 200 feet from the base. The angle of elevation to the top of a lighthouse. The angle of elevation is from horizontal looking up, so it's here, 55 degrees. How tall is the lighthouse? Here's the lighthouse here. Please change calculator to degrees. So you have to change the mode to degree. So this is opposite. X is opposite and 200 is adjacent. So this is tangent 55 degrees equals x over 200. Cross multiply and solve. And x is equal to 200 tan of 55. And again, you'll know at this point if this is set correctly. So this is going to be 285.630 feet. Again, you round it to 3 decimal places. And 49. Chuck is traveling down a mountain. The sign says the degree of inclination incline is 7 degrees. So this is 7 degrees. It's traveled 1 mile, which is 5,280 feet. How many feet in elevation? That's why I did the 5,280. Is the truck? Has it fallen? So for number 49 here, this is opposite and hypotenuse, so sine of 7 degrees is x over 5,280. Go ahead and cross multiply to solve. And x equals 5280 sine 7. Again, this is in degree mode. And x is going to be equal to 643.470.